Hello, folks. Hello, everyone. It's been freezing cold here, 15 degrees Celsius probably, somewhere around 60 to 65 Fahrenheit. So I was just warming myself up so that I can be comfortable with all of you. I think we are good to go now. So anyway, it feels great to be here. It feels great to be here with all the students in this Microsoft Student Summit Africa 2021. The organizers have been amazing, and I think we have got an amazing pool of learners and so many brilliant folks out there sharing their knowledge. And as we all know that I am going to talk about sensors and actuators because those are the stepping stones into Internet of Things, what we call IoT. And we'll be also unlocking the human aspect of machines so that we can better understand how sensor and actuators work. By the way, let me introduce myself. My name is Mohammad Iftekher Ebne Jalal, and you can call me Iftu. I love talking about community, IoT, and accessibility with younger folks like you. I think we can start today's session. So, what are we going to learn today? We'll be learning about the idea of origin of sensors and actuators. We'll be learning what sensors are, different types of them, and most importantly, when we are going to build some projects, exactly what are the things that are required to be done while choosing a sensor. We'll be learning same things for actuators as well. What they are, what they do, different types of actuators, and what do we need to consider while buying them, all these stuffs. And also, we'll be slightly talking about different microprocessors or controllers and virtual devices that can help us build a project without physical hardwares. And at the final session, at the final segment of today's session, this part, I will walk you through how I build a project, how I build a solution to something, so that you can better understand the approach of going with sensors and actuators. Anyway, before before I dive into today's topic, let me share a story with all of you. It was just a year back. A very cold, hazy morning out there, around 10 degrees Celsius, 5 or 6 a.m. in the morning. Nobody was on the street at that early, and one of my uncle was standing there by the road, moving his limbs, just warming himself up, preparing himself for his day, for his office, and all of a sudden something terrible happens. Something that just changed his life entirely. What happened was that a car that was coming at around, not just around, it was more than 100 kilometers per hour. So that much speedy car just hit my uncle, and what happened is severe head injury because the way the car hit him, he was struck somewhere in his head, so he lost his vision, and all he could see after the treatment is just darkness. Let me tell you what he says. This darkness is what he gets to see every day. And this particular incident really touched me. It really made me feel a realization, and a realization of responsibility. The only question I asked myself right away after the incident happened was, is there anything of significance that I could do to prevent, or at least try to prevent, my uncle's visual impairment? I want all of you to remember this incident, because at the later part of today's session, we'll be getting back to it, and we'll be developing something that can help people, with problems like this. Now let's get back into today's topic, sensors and actuators. If we talk about human sensors, there are basically five types of sensors. It's eyesight, hearing, taste, the way we touch something, our skin, and fifth, it's smell. So, five human senses: eyesight, hearing, taste, touch, and smell. These give us the idea about our surroundings and help us assess the situation. So, let me just think. Does our skin decide if fire is good for it or bad? Does our tongue decide if chocolate cake tastes good? No. We, as we all know, it's this roundish little thing stuck here, and it's called a brain that processes this data, and it decides that fire is not good for your skin. It decides that chocolate cake tastes delicious. In fact, with the help of these human senses, our brain decides our actions, what to do and what not to do. So I think the entire chain is very simple. First of all, we get information from external world. Then the data processing happens, based on which we decide on our actions. And what are the organs that basically do there? We have basic five organs that receive the information. Then we have our brain to process the data, and finally we have muscles to respond according to the scenario. Now let's compare it with a machine, how we can uh, project this property into them. So just like our sensory organs, they also require sensors for collecting the data, and comparing with human brain, they need processors or controllers to analyze those data and to give directions, to tell actuators what to do. And those actuators work like our muscle, they just do certain things as instructed. And as you can see on the screen, here's a bunch of sensors and actuators, and these are some of those basic things. So what are some basic sensors and how do we get data from them? Let's talk about them. Here you can see an IR sensor that can detect infrared rays. I mean, it operates in infrared rays, and it is being it is being used in quite a lot of applications. Seen I have seen it being used in motion detectors, and also those small automatic doors you have around in the offices. And these are basic things I have seen with infrared ray sensors. Next up, we have sonar sensor, also known as ultrasonic sensor. This sensor deals with sending and receiving sound waves, very common in collision avoidance device and object counting. So then we have temperature sensor, and in most cases temperature sensors are added with humidity sensors for the hobbyist project. So what you get is a humidity sensor and a temperature sensor as a whole. And then you can see that there are different buttons that can detect if we have pressed something or not. We have a smoke sensor to detect certain kinds of gases, and you have cameras for visual data. There is also something called an accelerometer, which can detect if something has moved in linear direction. In one recent project helping old people avoid a fall, they used gyroscope, another type of sensor which detects motion in different directions. Lastly, something that all of us use every day, it's microphone, which also is a type of sensor that senses our vocal sound. Let me show you some of the sensors I have right now. I think this is the sonar sensor I was talking about a while ago, and um, here you can see it's a button that you can press. So it's also a type of sensors. Here is a flame sensor that can detect fire. So these are some of the sensors we have. So how can we classify the sensors based on signal type? There are basically two types of sensors, analog and digital. The analog sensors are the ones that receive analog values. Right now, however I'm talking is an analog signal. My voice pitch goes up and down, my sound is being changed, the frequency with which I'm talking also gets changed, and all these properties are just changing in every moment. And that is how a analog signal works. And those analog sensors receive these sudden changes in voltages, records them and uses later. Let me share something with you. I think you can say this. It's called a potentiometer, where you can change the resistance of something. And as you can see, we can rotate it like just like this. Yes. So when we rotate this, the resistance value gets changed. So think that the resistance value goes up, 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 up. When I have put it in the full swing, then I am just changing it, changing it, changing it, and it just goes down, 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 down. And whenever I am also again turning it into the positive direction, it also goes up, up, up. So it's more like a sinusoidal wave that can happen if I move it in proper ways, but I think it's quite tough to move it in a way that can produce sinusoidal signals. Anyway, the idea is fairly simple. In digital sensors, either you are in on state or off state. There is no in between, on or off. But in analog sensors, you can have different values, you can have different data points. So that's how these sensors work. But now we all know that modern machines are the digital ones, and how on earth they get to understand these analog data? They can't. So what happens here is that whenever an analog data is picked by the sensor, there is something that helps the machine to understand it. For an example, my native language is Bengali, and suppose you don't understand Bengali, you are comfortable with Swahili or English. How can we bridge the gap? We need an interpreter, we need a translator, a middleman to communicate in between us so that we can understand each other. That's what happens here. Whenever an analog signal is taken, there is an ADC, which is also called as analog to digital converter. And what it does is that it just changes that analog signal into a digital signal, which is just on or off, on or off. And that's how the digital signal works. For an example here, my analog speech is being converted to digital one, sent to your machine, then your laptop, your phone or your computer just changing it into an analog sensor once again, and I mean analog data, and then your speaker is playing my sound, and that's how it's happening. Now we are going to see something very important. Every time you go on to build the project, you need to pick the right kind of sensors. So I personally follow 5 steps of choosing the right sensors. First of all, analyze the problem you have with you right now and understand the solution, understand how you're going to build the solution. For an example, if you want to know if an static object is replaced or not, how you are going to do that. For an example, if I want to know if my ball it has fallen from my table, how can I know that? Well, some people may suggest using GPS sensor because GPS sensors allow you to know your location, but that's not going to happen because the range of GPS sensor, the precision, and it probably will not be able to detect the fall of my ball from table to the floor in that much precise level. So I will be needing to use accelerometer or gyroscope there, which can detect if it has fallen. So that's how we need to make the right choices. There are also like numerous light sensors like photodiodes, phototransistors, and photoresistors, which are also called as LDR, and we just need to know the subtle difference between them and choose the proper one. You need to be the one deciding how the entire thing is going to go. So the next important thing is the range of your sensor. If we go through the data sheet of the sensors, we can see what is the range of their operation, because there is some limit to their working. So we need to be considering what is the range and certain types of sensors. For example, we can consider this sonar sensor I have, which is HCSRO4 version, and you can see the datasheet of it. Next up, we need to think about the resolution it gives us. It is the most granular increment detected by the sensor. If the previous example, in this previous example, the resolution was around 0.3 centimeter, so that's the unit it calculates progression, and it can be one of the most crucial factors, if not the most, in terms of deciding how precise your data is. Fourthly, we need to consider being model fit. We need to consider the sensors being model fit. What does this fancy model fit jargon even mean? Suppose you have a tiny little bird of yours and you want to know its location. So as we have already discussed about GPS sensor, suppose you want to install a GPS sensor into your pet bird. But here comes the catch. There are different kinds of GPS sensors. Some are quite heavy, bulky, and some are extremely light. So if you are installing a bulky solution, what's going to happen? Your bird won't be able to fly, and that's where you need the lighter GPS sensors. So being model fit requires here to be of less weight. There can be other factors, factors like how the material of the sensor is, how it was built. There can be things like the temperature it gets destroyed. There can be things like the pressure it can withstand. So these are the things you need to consider, and we cannot generalize them because it depends on the solutions, it depends on the project you are working on. So you need to figure it out if the sensor you're working on is following the model fit. Fifth, this is the final touch up, and I just put this because I wanted to have a little discussion about this cost, efficiency, and longevity. In the hobbyist projects, I mostly think about using less expensive materials to develop the prototype. But but if you are launching your solutions commercially, then using these cheap, less expensive sensors may cost you a big deal, because the performance needs to be up to the mark. The sensor need to be long lasting, and you cannot keep a tiny piece of plastic being exposed. You cannot allow lower grade materials. So once you go commercial, the whole scenario changes. For now, as hobbies, you can just pick one, but if you are going to go commercial, then use commercial graded products. So we had been talking about sensors, and now we will be getting back to the processing unit. When the data is collected by the sensor, then it goes to the processing unit. So what are basically the units that you use? There are two basic approaches most people use. Not approach, they are just devices. As you can see, this is Arduino Uno, and this is what I have been using since I started getting into IoT. And also there's another device which is called Raspberry Pi. Remember the fact that this is a microcontroller, Arduino Uno, and Raspberry Pi is a microprocessor, and there lies difference between these two that you need to be considering about. So next up we have actuator. In case of actuators, what they do, they basically reacts according to the direction, according to the directives they receive from these microcontrollers, and they act accordingly. There are different kinds of actuators, kinds as in use cases. Like LEDs are actuators. There are actuators like this is a stepper motor. This is also an actuator that just moves according to the directions it receives from the microprocessor. Also, you will be getting to see different kinds of, this is an LCD display and it shows the output. That is why it is also an actuator. Just like the sensors, there are two basic types of actuators in terms of signal: the analog actuator and the digital actuator. I think you can relate to this idea of dimmable light, where in a light you can control the brightness by just turning the knob. As I had showed you earlier, just turn the knob and you can control the brightness of the light. Since LED is an actuator, it means that if you are controlling its signal by different value points continuously, it's an analog actuator. And also there are different digital actuators, like there are LEDs we use, they either turn on or off, simple. So that is a digital actuator, and that's how we basically function. And just like the ADC converter, here is also a DAC converter, which is called digital to analog converter, which takes the input of digital signal and outputs an analog signal, and that's how these actuators basically function. And for choosing the actuator, you have quite the same, those five parameters or checklist you need to have. So these are basic things about actuators. Now we will be moving on to building the hack. How can you use sensors and actuator to build a real project, a real stuff? So we are heading towards the end. Remember the story I told about my uncle? Let's build something for him. We will be building something for him. Well, so I basically build solution in 5 simple steps. First one, identify the problem. What exactly are you going to address? In this case, in my uncle's case, we need to help him because he has disability, he has difficulty in seeing something, and what happens is that because of that he may stumble on the roads, on the streets, he may collide with an obstacle or something else. So he needs to be alerted every time there is something in front of him. Then again, there are different types of other dangers that can happen which are not particularly objects. For example, if there is fire in front of him, and since fire is not an object, it will not be possibly detected by the method we will be using. So we need to get the data for fire in a different manner. And also we cannot forget the potholes on the road that we have. In those potholes sometimes there are filthy waters, and that are basically not good for any person. So we have basically identified 3 problems. We'll be solving his obstacle detection, will be solving his problems of fire detection, and also he will be able to know if there is clogged water in front of him. So that's how we are going to identify the problem. Now, step number 2, design the solution. How is it going to work? To avoid obstacles, we need to know if something is there within probably 1 meter region. So we need to have a sensor that can detect the distance between a person and object in front. How will the sensor be carried? That's another question. We can attach it to a stick or something like this, and then just place it on it. It will be a longer stick so you can work around with it, and that's how we can stick those sensors to it. And for detecting the object, for detecting the distance or obstacle, I think it will be a very good choice to choose sonar sensors. And then we will be sending the data to our Arduino Uno, and then it will be giving us the output of buzzing sound, the output of vibration, so that he gets to know there's something in front of him. Now the second one, fire. Since sensor is going to be attached to the stick, direct proximity or being in touch with fire is required in that case, and it might be late before he can back off. So it's better to use a smoke sensor that can detect smoke, because smoke travels and travels much farther away from the fire, so that he will be getting to know that there is danger in front of him. And thirdly, we can detect the clogged water by using some voltage divider circuit, because we know that water is basically a conductive material, a current conducting material. So if current passes through certain paths, it will alert him by buzzing or vibrating. Now, step number 3, choose the hardware. We have previously discussed this, right? We can follow the checklist and pick the right hardware. So I'm deciding, as I have told you earlier, I'm deciding sonar sensor for this. I am deciding to go with MQ2 sensor for detecting smoke, and the presence of clogged water will be sensed by using a voltage divider circuit. And if someone wants to use sensors, you can use rain sensor, or there is something that can detect water, so you can go with that as well. And as I have previously said, we'll be using Arduino Uno for this project. So step number 4, building the hack. Now you need to develop, put the logic, do the coding, circuit connections. Those are the parts that I am going to skip today because today's topic is just on how actuators and sensors work. And so the fifth step is going to check the device yourself, test and debug it, and keep debugging until it's a well sorted product. Congratulations, thank yourself because you have built something. Let's see the solution working. With the use of sonar sensor, we are detecting the obstacles. So we can hear the buzzing sound whenever there is obstacle and nothing when there isn't. Whenever there is fire, it will start buzzing and also vibrating. As you can see, here is water and that's why it's buzzing and vibrating. Now, what if you don't want to buy all the hardwares? You cannot work with them. So in that particular case, you can go for virtual hardware. There is something called Counterfit, and as you can see in the video, you can install it by using pip packages. And I think I'm not going to describe it, but you can see it from the screen how I am going about it, and hopefully you'll be knowing about this in the future sessions. So first of all, we need to write pip install and then counterfeit. When you are writing this command to the command prompt in Visual Studio Code terminal, you will be seeing it being installed. Let's just wait and see. It's coming. um, I think okay, let's just wait for a few more seconds. Yeah, yes, done. First part is done, and now we'll be entering the second command. It's just pip install counterfeit connection, because we need to connect from our local machine to the counterfeit. Okay, so I think it's coming. Yeah, it's done. Now we'll be writing the counterfeit shims grove, because we'll be using grove sensors. Yeah, I think it's done right now. Now you can enter the command counterfeit in the VS Code terminal command prompt, and then you will be seeing something like this. In the browser, this counterfeit window will open up with sensors and actuators, but please be noted that it will be seen as disconnected, and in the address bar you will be seeing the localhost address that we need to put. So I think from the screen you can see what we need to write, and once we enter this, it will be getting connected, and that's how we basically start our journey with counterfeit. I will be dropping the link on how to install it, how to work with it, so that it becomes easy for you. Now, before I end up, I want you to take back something today. I have listed down a few resources here. Hopefully, you can see the link on the screen right now. Check them out and just keep learning. So, I wanted to end where I started. My uncle's unwanted accident. I must say, people around the world look at us developers and find us surrounding ourselves with baggage of academic projects, circuit assignments, hours of bug infested coding. Still, what they miss is at the end of the day, when you turn your laptop off, when the light gets out, we also ask ourselves the one most humanly question: what made our laborious projects and hours of back-breaking engineering meaningful? What to do it all for? The answer is that I found will be wrapped up in a quote by one of the popular American author Zig Ziglar. He said, and I quote, "You can have everything you want in life if you just help enough people get what they want in life." So that's all from my side. Thank you.